All right, gang, welcome back. Here we are. We're in Module 7. Now in Module 7, we're going to deal with deep learning. I've got both Intel content as well as a chapter in the book. There's going to be a lot of overlap, but I want to start off with the Intel content because they got a better graphic. That graphic is right here. Now, AI is a huge field. And within AI, a subset of AI is machine learning, where we're using algorithms that get better over time and they help us predict things and classify things and perform tasks. Now, a subset of machine learning is deep learning. Now, traditional machine learning is either supervised or unsupervised. Supervised is the darker of the two, and unsupervised is we're jumping down into this machine learning, or I should say the deep learning. Okay. So with that said, deep learning has available to it everything in machine learning. Machine learning has available to it everything in artificial intelligence, but AI is not necessarily machine learning. It could be. AI is not necessarily deep learning. It could be. So they're each subsets of the other. All right. So differences between machine learning and deep learning. In machine learning, we have knowns, and we're guiding the machine learning a lot of times and saying, here's what you need to look for. We're kind of telling it what the rules are. We're telling it what the algorithm is. In deep learning, we're saying, here's the image, figure it out. And it goes back and forth between these layers to figure out what's what. Now, there's a distinct difference. Deep learning is far more complex, far more resources required to do the work, takes longer to do. Okay? So it's higher level, if you will. So deep learning can solve both supervised and unsupervised. We're not limited to just unsupervised in deep learning. It does it all. Whereas machine learning is traditionally just the supervised. Okay. So we could be doing classification, detection, whatever it may be, but these are deep learning. We've got semantic segmentation, to where we're actually identifying specific pixels by area to identify the object. We've got natural language object retrieval. And in this, we're using NLP, which is man far right, or left guy, or cyclist. That's a natural language phrase, word, term, whatever you want to call it in this context, to be applied to an image. So we're using both NLP and object detection. It's kind of complex. We've got speech recognition. That's deep learning, because there's a lot of learning that takes place. And the tone of the voice, the level of the volume, the cadence of the language, maybe the same language, but those things all vary. So we need a lot of inputs to be able to perform speech recognition and language translation. We've got what are called fully connected networks. Now, back in videos. Chapter 1, we talked about neural networks and the fact that this AI, the machine learning and the deep learning, it works kind of like the human brain works. And the neurons are like CPUs firing off in there. Well, we kind of compare it to whatever we know, and that's what we know. We know about the brain to a degree, kind of how it works. So we know about supervised learning based on previous modules. Which model do we use? We got to feed stuff in to a neuron and then it classifies. Well, now we're feeding in the data. The data has a specific weight. We may also feed in a bias, and then from there the system goes and processes through that neuron. And that neuron, we have an activation function that's taking place. We don't need to dig deep into this. I just want to give you an idea of what's taking place. So there's levels of classification. It's not like, oh, we go through everything and the classification happens at the end. We may go through and do some classification step by step along the way, subgroups, and then go from there. If we were trying to figure out if it's a dog or a cat, well, what's the shape of the tail? How tall is it? How many legs? Shape of the head, things like that. Each one of those is a different level of classification. Okay. A perceptron is something that we will see in deep learning. We don't see it in traditional or general machine learning. Okay. So in deep learning, we've got different layers. We've got the input layers. We've got hidden layers along the way, and each one goes to each one of these neurons in the hidden layers, and then from there we go to the output layer. Which classification is it? Class 1, 2, or 3? So in deep learning, we're doing similar to what we did before, but there's a whole lot more complex work that's taking place in here. And in this example, we see one hidden layer. There may be a dozen layers in here of a variety of different types, all to get down to the classification. It's not as simple as what we looked at in traditional machine learning in previous modules. Okay. As we get to convolutional neural networks, it gets even more complex, and we get into images, RBG, red, blue, green, 3 different layers. It's 3 different groups of data that we're having to deal with all at once. So I'm not going to dig any deeper than we already have on this one. Let's jump over here to the text for deep learning. Now, like I said, much of this is going to be a rehash. So there's differences between the deep learning and machine learning. We talked about it. We talked about the similarities between the brain and deep learning. We've got data coming in, it's got to wait. Data coming in, it's got to wait. And it's almost like saying this one's important and this one's not as important, or maybe more important. And then we've got a bias that will come into play, and this is going to be a 0 to 1 value, that it's almost like saying here's the value that we apply to this math to have it pop out the other side. Okay. And they break it down here. This bias helps to smooth out the calculations along the way. And this is our algorithm, the math that takes place as everything comes in and goes into this hidden layer. Now this looks generic. Oh, here's just a big circle. Think back to the PDF that we were just looking at, and that hidden layer may have had 9, 10, 12 neurons in it. It's a lot going on. and each value is getting passed to a copy of each value is getting passed to each neuron. And then that gets passed forward to help it decide what's what. Backpropagation allows us to, we've got weights, bring things, pass it forward to a hidden layer, it does its thing, and then it realizes, wait a minute, let's change the weights. And it goes through and it modifies those weights to see how does that impact the accuracy. So it's an iterative process that learns along the way as we modify different weights, what's the impact. That's what we have when we're going back and forth and modifying these weights. Like I said, that's something we'll deal with in a future course. Just keep in mind that now, instead of there just being one layer in the middle, we've got multiple layers, and we're essentially going back and forth between the layers at times, or cycling through all of them and modifying values as we go along. Deep learning is being used for detecting Alzheimer's, for energy. So NextEra, as most of you know, NextEra's home base is up in Palm Beach Gardens. That's the parent company for Florida Power and Light. They have what's called a smart grid. They utilize deep learning and IoT sensors to know where to produce power, when to produce power, when there's an outage, how to predict outages. This is all done in deep learning, in real-time monitoring and reactions. They become very efficient and very reliable as a result. Predicting earthquakes, where the next hurricane's going to end up, radiology, detecting cancers. The hardware that we're using is far more robust than what we would need for traditional machine learning, because there's so much more work going on. The more work you got to do, the more resources you're going to need to do it. Resources are expensive, whether it's the capacity of the computing, the CPUs, the RAM, the hard disk space, the network throughput, time associated to do it, the money invested in the system. Can I outsource this? We look at the initiative to is Microsoft building the equivalent of what we're talking about here, or it could even be the other that I said we'll talk about later on, the quantum physics system that allows us to perform these tasks so much faster. Things that we would look at as a traditional computer would never be able to complete the task. Quantum computing will be able to complete it, and quite fast. So it's a huge comparison, saying, well, we'll never be able to do it. Not just within my lifetime, but yeah, it's not realistic. We don't have the capacity to do it. Whereas, yeah, we're going to be able to have those machines. They will be working by the end of this decade. So within the next 5-6 years, we should be able to have, somebody should be able to have a quantum computer up, running, and have it reliably working. Systems exist, they're just fine-tuning it. So there's a variety of different drawbacks that exist. There is no one-size-fits-all. Data is a big deal. The structure, how we think about things is not how the computer thinks about things. Deep learning can't determine causation. It just finds correlations. So there's a correlation between this and that. What did this cause that? The computer doesn't know. It just knows there's a cause, or there's a correlation between them. Resources, as I said, one of the biggest things that we're dealing with. Overfitting. We talked about it earlier. It's a big deal. Okay. So here in Module 7, in the overview, I went through everything that we've got to do, but one of the things that you'll see as a graded item that wasn't in the overview, something that was added late in, is the unsupervised learning analysis and using Orange. So I'd mentioned in previous lecture, piggybacking off of the Orange assignment in Module 6, you've got another Orange assignment here in Module 7. The first video in that series was the Module 6 assignment. The last video in that series is the Module 7 assignment. I encouraged you in the last module to go through and watch those videos in between. I didn't want you to necessarily have to go through and go along and do everything that they did. You can, in theory, get through that last video without going through the in-between ones, but it's better to go through them all and have an understanding of what you're doing rather than just trying to get by. Okay? If you got questions, ask them. We'll see you in the next module.